Hi, it's Dr. Z. In this video, I'll be introducing the concept of correlation coefficient. By the end of this video, you'll be able to understand what is a correlation coefficient and be able to calculate a specific type of correlation coefficient called a Pearson correlation. This video will require you to take notes on the lecture handout. Please feel free to pause the video at any time to take notes. So, what is a correlation coefficient? Coefficient is just a fancy word for a number or value. In the previous lecture video, we learned that a correlation is a relationship. Well, when put together, a correlation coefficient is a single number value that tells you about the relationship between two variables. To calculate a correlation coefficient, we need to review the logic behind each step. The logic will then inform what type of math or calculations we will do. Let's return to the earlier example of the relationship between ice cream sales and weather. How are ice cream sales measured? In dollars, right? Well, how is temperature measured? In degrees Fahrenheit. So we have dollars and Fahrenheit, and they're not the same measurement. So we have two different variables that are like comparing apples to oranges. How do we compare apples to oranges? Well, we can't. Rather, we have to convert them both into pineapples to compare them to each other. Therefore, we have to convert the x and the y scores into z-scores. Second, since we have two variables, we have two scores for each person. We have to take into account both of these scores. Therefore, we will multiply the z-scores of the x variables with the z-scores of the y variables. We also refer to this as a cross product. Third, recall that the simplest definition of the word coefficient is a single number. So guess what? We need one number to explain the correlation. Therefore, we will sum up or add up the cross products from the previous step so we can get a single number. Finally, we need to account for sample size. Therefore, we will divide the sum from the previous step by n, or the total number of participants. Phew! That was a lot of steps to get to a single number value of correlation coefficient. We will now review the specific type of correlation coefficient to be calculated today. If you remember, correlations have several different patterns, such as linear or curvilinear. As a result, there are several different correlations that we can calculate that are specific to the pattern being measured. Today, I will introduce to you the Pearson correlation coefficient. This type of correlation measures the degree of a linear correlation between two variables. So, if we go back to the title here, Pearson is referring to linear, correlation is referring to relationship, and coefficient is referring to a single number. In other words, we're calculating the number value of a linear correlation. In statistics, we like to shorten everything into a single letter for notation. So, what do you think Pearson correlation will be? Did you say the letter P because of Pearson? Well, that won't work because we already know that P stands for probability or proportion. So we have to change it up completely. The statistical notation is R. Did anyone see that coming? Now for the formula. The formula looks a bit overwhelming, but I will break it down into its parts to make it easier to understand. Recall that we have two different variables that we have labeled x and y, and that those two variables we have to convert into z-scores, so that's zx and zy. Then we have to multiply zx times zy for the cross products. Then we also need to sum it all up to a single number, so we add them together. And finally, to take into account sample size, we divide by n. If the description of the formula sounds familiar, It should. That is the logic behind a correlation, which we reviewed earlier. So, are you ready to calculate your first Pearson correlation? There are 4 basic steps to calculate a Pearson correlation. First, calculate the mean and standard deviation for each variable. I will be nice and provide them for you today. Second, convert those X and Y scores into Z-scores. The star here is to remind you that we already know the Z-score formula. You may have to look back to your Chapter 3 notes. Third, calculate the cross product of Zx and Zy. In other words, multiply all the Z-scores for the X variables with all the Z-scores for the Y variables. Fourth, we calculate R by adding up all the cross products and divide by n, as indicated by the formula. This week's lecture example asks, what is the relationship between sleep and mood? A researcher asked n equals 5 students how many hours of sleep they got last night and how happy they feel on a scale of 0 to 8. Sleep is considered the X variable and mood is considered the Y variable. Please see the table in the lecture handout for the data. The data for this lecture example is provided in the table in your lecture handout. Please note that there are 3 extra columns that are not labeled. Please label these columns ZX, ZY, and ZX-ZY. This is to keep your table organized to avoid making any mistakes. Step 1 is to calculate the mean and standard deviation for the X variable and the mean and standard deviation for the Y variable. Fortunately, step 1 is already done, as the mean and standard deviation are provided for you on the lecture handout. For the X variable, m equals 8, SD equals 4, and for the Y variable, m equals 4 and SD equals 2. Step 2 is to convert all the X scores and Y scores into Z scores using the Z-score formula learned in a previous chapter. The most common mistake in this step is to use the incorrect mean and standard deviation in the formula. For example, for the X variable, we will use mean of 8 and an SD of 4, and the X score of 2 to calculate the Z score of Z equals a negative 1.50. You will then place the final answer in the table here. Now, let's practice for the Y variable. We will use the mean of 4 and an SD of 2, and the Y variable of 1 to calculate the Z score of Z equals negative 1.50. You'll then place the final answer in the table here. Please pause the video here and calculate the Z scores for the X variables and the Y variables on your own before we continue with the next step. Before we continue with step 3, let's confirm your calculations for the Z scores of the X variable and the Y variable. Step 3 is to multiply your ZX and ZY scores. For example, for person A, we will multiply the negative 1.5 and the negative 1.5 to get a ZX-ZY of plus 225. The plus 2.25 is our cross product. You will then place the final answer in the table here. Remember that a negative number times a negative number always gives you a positive number. Please pause the video here and calculate the remaining ZX-ZY scores on your own before we continue with the next step. So let's confirm your calculations for the remaining ZX-ZY scores. Remember that 0 times anything will always equal 0, as in these last two values. These Zx, Zy values will be used in the next step. Step 4 is to calculate R using the Pearson correlation formula. This formula is telling you to sum all the Zx, Zy cross products and divide by n. In other words, you will add up all those Zx, Zy values from the table and divide by 5. The final answer is R equals plus 0.95. Please do not forget the sign of the R value because the sign helps with the initial interpretation of the correlation coefficient. We will now have a video intermission. As part of the Nearpod lesson, you will provide the initial interpretation of this correlation coefficient value.